off. So I guess first of all, thank you very much for everyone joining us today. Today is the first day of the .NET conference. We're doing different talks over the next 3 days. So please don't forget to check kind of the topics for tomorrow and also Thursday. And we'll be happy for you to join us over the next few days. I suppose I'll start with just a quick overview of the format for today. So the first part of the presentation would be Piotr's presentation. And then in the second part, we'll save some time for Q&A. In terms of the questions, there are two main ways to take part in the Q&A. So there is a Q&A option that you should see in Zoom. So you can type in your question there and we'll go through them, as I mentioned, in the second part of the talk. And then if you want to make a comment or share your experience or just ask your question by speaking instead of typing, you can also use the raise your hand option in Zoom. And we will give you the chance to speak as soon as possible. So to move on to some short introductions, my name is Albena Krasteva. I am Head of Tech Relations and Growth and Zartis. I will be the moderator of the talk, going through the questions, etc. And our speaker for today is Piotr Litwinski, a principal engineer at Zartis from our Wrocław office in Poland. To give you a short background on Zartis, we are a digital solutions company with 100+ engineers distributed across different offices in Europe. We help companies foster improvement in how they build software, but also get applications built in a faster and better way through services such as nearshoring, staff augmentation, and consulting. We partner with companies across many sectors, including e-commerce, logistics, fintech, medtech, renewable energy, among others, to help customers achieve their business goals. And as a company, we have extensive expertise in the area of .NET. We have numerous engineers and very large teams working with Microsoft technologies. So the purpose of organizing and hosting this conference is to, on the one hand, share our experience, but also to learn from the questions asked, from the insights shared by our participants, our external speakers, and of course, all of you guys as attendees. So to introduce our speaker for today, Piotr. So Piotr, as I mentioned, is a principal engineer at Zartis. He has many years of international experience working on highly scalable microservices and event-based architecture. He is an expert in .NET with multiple Microsoft professional certifications. He has strong expertise in multiple cloud environments, including AWS and Azure, and various microservices orchestrators like Kubernetes, ECS, Service Fabric, etc. He is passionate about process and test automation, which leads us to the current topic of today, testing microservices. So Piotr, I leave the floor to you.
Thank you very much, Albena, for introduction. First of all, I would like to welcome you all. Thanks for joining us and spending some time with us. So today, as you can see, I'll be talking about testing microservices in .NET environment and ecosystem. So first of all, I would like to highlight that basically this is a little bit opinionated standpoint, mostly from developers' perspective. So this is not exactly like so this is not quite like a QA approach, and so there might be some definitions that are used differently by QA teams or QA people. So this, like I said earlier, this is purely very opinionated from developer perspective. So what are we going to talk about today? Yeah, first of all, we're gonna talk about what is the issue with the testing microservices as a whole. Why do we test in the first place? We'll talk about layers of automation. Uh, we'll discuss what tools to use, and in the end, we're gonna talk a little bit about conclusions, and we'll have a short summary of things. So, first and foremost, why are we actually testing? What is the problem with testing microservices, right? So basically, the biggest issue is that in microservices distributed environment, we have a lot of moving cogs within our systems or subsystems. So it's constantly changing. So very often that in monolithic environment, we would have just everything one big blob of things. Deployments are hard, but once they're done, everything is either working or not working usually. With microservices, it's a bit different because it's constantly changing. Like I was saying earlier, there is like a lot of services interacting with each other. So we like to have as much confidence as possible, but it's not always that easy as it seems. Regression is also very hard because if imagine that you have like 10 teams and they are constantly working on various different aspects of your system and and they're just pushing stuff to one end, and your team is pushing to another subsystem, and then there are some side effects of those changes because you weren't aware of the changes from another team, kind of stuff. So this is getting very, very complex and very often very, very hard. Also, if you have manual regression, it usually takes quite some time. Very often it takes days or even weeks sometimes if the system is complex enough. And last but not least, I think the rollbacks are usually not trivial because of the whole dependency tree in a sense. Kind of like taking out one of those cogs from the whole machinery might be really difficult because that usually implies that you need to also revert some other things and other things and other things. So yeah, basically you try to avoid rollbacks and try to avoid deploying issues to production because that basically it causes problems, but it's also very, very complex to kind of like handle it very often. So why do we test in the first place? Well, so first of all, I would say it's peace of mind. So to kind of like cater for stuff I was mentioning earlier. So to make sure that to best of our knowledge, software that we're delivering is working as expected. It's not causing any side effects or any issues. But also, there are other things that are are worth to mention, especially from the developer's perspective. So very often it speeds up development. So imagine that you have like 10 15 different services, and you have a feature that's kind of like maybe not directly touching all of those services, but they're triggered by other services. So I guess some of you might have experienced that by like downloading 10 different services to your local machine, starting say hitting an API. That API is doing something, and then it produces a message. Then it goes further. It's picked up by another service that later on processes again and produces say 2 other messages and so on. So you get gist. So basically, running it and configuring and setting it up locally is very very difficult. So if you're kind of like having all this stuff scoped a little bit, you can test it in isolation. So you can use tests to kind of like have your hosting environment for development purposes, at least at the early stages of development. And the third thing I think it's worth to highlight is that very often it's sometimes there are scenarios that are really hard to reproduce in real world. Like for instance, imagine that you'd like to cater for third-party outages. Like imagine that you have like a third-party cloud service, and you need to test if your system can cope with any issues coming from that external API that you have no control over at all, right? So you probably don't want to break it because it might break something in production, but on the other hand, it's very difficult to kind of like simulate that, right? So with scoped software and kind of like using tests for development purposes, it's much easier because you can simulate those different states by using various techniques I will be talking about later. So that brings us into layers of automation. So in here, we'll be talking a little bit more about what types of tests we have, how they cope with each other, how that stuff works together. and we're gonna talk about testing parameters. So a lot of you might have heard about it. It's pretty common concept. But just to briefly put a theory for everyone. We have like as you can see there is a pyramid. So at the bottom we have like tests that are very cheap, fast, and easy to develop. Like for instance unit tests, and then the further up we go, the tests are getting more complex, more expensive to maintain, to develop. They're slower in terms of running. So as you can see, unit tests are, for instance, very cheap and very fast and easy to write, because usually the piece of code that you're testing is very small. Then you can have, for instance, like functional tests. You can have integration tests. So functional tests are usually some sort of, they're grouping a bit more classes, or a bit more units of code, and then integration tests are usually interacting with something else, and then end-to-end tests are testing either like your system or a subsystem. So basically there are differences between some of them. So we will be talking about it later, but the bottom line here is that there are various tests that you can use, and basically you need to think about upfront and how do you want to test different parts of your feature, right, or various features, because sometimes it might be enough to test it on a unit level, but sometimes it's just not possible for various reasons, right? The feature might be too complex, or it's too difficult, or it might not be reliable enough to test on lower levels. But the idea is that with a testing parameter, we have like some sort of layers that we basically put one on another, and basically we rely on things that are lower on the pyramid that has been covered, and then we're just kind of like covering things that couldn't be covered on lower layers. So how does it look on the a little bit more in practice, right? So how the layers look in practice. So as you can see on this diagram, it's just for a quick overview. So in here, let's assume that we have like two services. There's load balancer sitting in front of them. So a request comes to load balancer, then it just distributes it to one type of a service. That there are multiple instances running on of that service. That service has its own database, and then that service translates those requests somehow into messages. So we have some sort of message bus. And then there is another service. There are multiple instances of that service that they're listening for changes from that message bus. It has its own own database, and let's say it's reporting or something, and there's insert stuff there. So kind of like how that looks in practice in terms of testing parameter. I kind of like mark the areas in here, and they're marked with numbers. So basically the idea is that you try you can kind of like put as much as you can those cheap and fast to implement tests within your service itself. So basically kind of like on a CI part, or even running it whenever you're running it locally. Then the second group of tests is kind of like trying to run not only the service itself, but also try to stop a few things here and there, like for instance use some sort of local counterpart, or maybe like local database, or some sort of Docker container or something like that, so that you can test a little bit of an integration, but you're not really integrating with real things, but with some sort of substitutes. And then third group is those are the slowest and hardest to develop and maintain, but also the slowest when you're kind of like testing everything together, and you need proper environment for that as well. So you need to kind of like deploy it, run it, see the results, wait for the results, and if something fails, it's not that easy to actually say what went wrong. So you need to look into that.
Piotr, if I can maybe jump in with a quick question here. I guess kind of from an overall strategy perspective, when is it critical to implement all of the levels of testing, and when is it just too costly and not worth it?
Yeah, that's very good question. Yeah, so I think that it really depends on the feature that you're implementing. Probably if it's something that's not really business critical, it's probably not worth like implementing all the layers. But if it's like the most critical part of it, the main core part of your business, right, it's probably good to have it covered with all the layers. So you can cut some corners here and there, but it really depends on the on your scenario. However, it's worth to mention that, you know, given that you're kind of like building layers upon layers upon layers upon layers, so in that kind of scenario, it's very often that they're not really that expensive after all, even for simple scenarios, because you have a lot of building blocks in place already, right? So adding those. So basically what I'm trying to say is that the more familiar you are with those techniques, the easier it is to follow, and then it's actually not taking that much time and effort. Okay.
Great.
That was a very good question. Thanks. Yeah, so now we're going to talk a little bit more about those types of tests and a little bit more about techniques. So in this case, I kind of like split it into certain groups. So as you can see, build time tests, so there are 1 and 2, and those 1 and 2s are referring to the previous slide. So basically, what can we do on the build time? So what we can do on the build time, or running it locally, because I think in this case it's very close one to another. So first and foremost, classic unit tests, I think it probably doesn't require that much of introduction. But then there are other things you can deploy. Like for instance, you can test your contracts. So contracts are extremely important because if you kind of like go back a little bit to what I was saying about scoping your services, your modules. Well, this is kind of like the key. So basically you can base all the stuff on the contracts, and that allows you to test those things in isolation because you're relying on the contract. So because of that, your contracts are very important to cover and to be tested. So the idea is that you're, in this case, you're making sure that your contracts are not changed somehow accidentally. Like imagine that you have API responses, let's say in ASP.NET, and you're replying in JSON. So your contract tests are verifying if you still have the same capitalization, if order of properties is still the same, if you know the arguments are, I don't know, case sensitive or case insensitive, you know, that all that kind of stuff, right? So for instance, if someone hasn't changed it accidentally from JSON to XML, because you know it's sometimes very easy to change the way how you're converting, how you're presenting the data. So those tests are heavily focused on just presenting the data. Then you can have service / component / functional tests. So it has various different names. So I'm usually using like functional tests for that kind of approach, but it might vary. So that's why I was saying it's a little bit opinionated, and terms might be a bit different for various people. But basically, the idea is that in this type of test, we're using a lot of in-memory counterparts, emulators, some sort of like some sort of stripped out versions of real services that are basically everything is running locally on your machine, right? So it's not necessarily just running on the same process, but basically you have everything running your machine. And then the last part is single service integration test. So usually that means that, say you're developing AWS, so you're using like a real DynamoDB instance, and you're kind of like trying to run against that for whatever reason, right? So usually you can use some other counterparts, but sometimes there are edge cases that cannot be covered otherwise. So this is probably it. But as you can see, even here you can see some sort of layers. So at the very top you have stuff that's very easy to maintain, and it's almost instant to see what's wrong if they're failing. And with integration tests, it might not be so easy. However, in here, I think it's worth to mention that this is mostly white box, or almost exclusively white box testing, which means that you need to know what you're looking for. You need to know how this stuff works internally if you want to write those tests, because very often you're just relying on some sort of replies from certain methods, or you're just flipping some sort of internal state, or you're changing something and then you're checking in the in-memory database or another API or something like that, right? So you need to know what you are doing here. So the next part of group of tests is environmental tests. And in here, well, as name suggests, you need some sort of environment. It doesn't need to be like full environment, but at least you need a little bit of servers here and there running, or containers, or whatever you're using to host your system or application. But well, in here, you probably need more than one, so you need to at least test it. You can use simulators to some extent, but at least the idea is that you'll have more than one service running at the same time. So there are a few groups of tests that can be put as environmental tests. So one of them is deploy tests. So those are tests that are basically run instantly after the successful deployment. And the purpose of those tests is to verify if all the stuff is configured properly. So this means that you don't really focus that much on logic. You're mostly focused on, I don't know, if you can have access to the database, if you, I don't know, send a message, and if it's being processed properly, so that kind of like verifies if you have access to all the resources that your service or a bunch of services actually need. Then you have end-to-end tests, so they're usually more focused on use cases. So you send an API, and you then later on expect some sort of notification being sent back by your system or subsystem. Next group of tests is kind of like it's in a sense a little bit similar to deploy tests, but they're a bit less flexible. Is startup checks. So that means that this is actually part of the deployment process of your service. So the idea is that you basically code in certain verifications and checks at the startup, and you make sure that when your service is deployed, you can, for instance, access database if the database schema is in the correct place, if I know APIs that you are using are in the correct versions, that kind of stuff. So those startup checks are verifying if everything that the service relies on, your service relies on, is actually working as expected, is in all the versions it should be, and so on. And then last but not least, those are exploratory testing, exploratory tests, and so they're semi-automatic. So they are mostly done by QA, QAs or automated QAs. To some extent, you can actually run a series of tests, automated tests on that, but basically you're just trying to figure out if there are any ways of break up the services and that they're being tested. So in here, I think it's worth to mention that in this case, it's a mixture of white box and black box testing. So because, for instance, for startup checks or deploy tests, very often they are more like white box testing, but for end-to-end or exploratory, you don't really need to know how this stuff works internally. The other thing that's worth to highlight between those two, between build time tests and environmental tests, is the complex split. So again, some sort of layers. That build time tests are focused quite heavily on the logic of your service, right? So you test stuff in isolation. You don't really care about all the stuff around it, like databases, APIs, and so on. You mock all those things. And you focus just on your logic, right? So you basically make sure that if you flip this, then it reacts in with the correct signal that you would expect. Whereas environmental tests are basically testing things, looking at mostly on the configuration, right? Because very often it might be a thing that your logic is working perfectly fine, but there are some issues related to configuration, like wrong password, expired certificate, or whatever, right? So environmental test purpose is to kind of like mostly to detect that kind of things, and also some sort of smoke tests and so on. But but most of the logic should be probably tested on the build time, because it is usually possible to do it. To do it. And then environmental tests are trying to catch and fish for any changes, because it might happen that you're running the same set of tests on each environment. So you might have like some sort of development environment, QA, and production. So it might happen that it works perfectly fine on your dev and QA environment, but it fails for some reason on production, right? So those tests should be indicative enough so that you can see why they were failing. And then there is also another group that also fits into the third part, which is the basically everything or part of your subsystem, or depends how you want to slice it. But those are system tests. So in here, I would say there are two groups that are worth to mention. It's performance and resilience and availability. So excuse me. So performance is related to performance of your services. So you kind of like, so this is very tricky part, because you usually don't need to have like a full scale environment for that, but it needs to be kind of like scale down, or kind of like tailored to be close enough, so that, for instance, you know, instead of running 10 services, you can run probably 2. And then you can kind of like say, okay, so if 2 services can hold that much load, then it means that 10 can, say, do 5 times more, right? So this is very tricky to how to tune it, how to prepare it. But basically the idea is that it needs to, those tests should simulate the real traffic, and basically the main purpose is to see how the system behaves in various scenarios. For instance, under a lot of traffic or a lot of stress, or if if it's overloaded and so on, right? And then there's resilience/availability. So this is more about how your system behaves in case something goes wrong. So imagine that you have like 20 services and one of them is down. So does that kind of like drag down the whole system down, or is it just kind of like causing a system to operate with, I don't know, some warnings like, hey, currently you don't have access to this part of the system, but other part is still up and running. So I think that so in this case, I think Netflix is very well known for doing that kind of testing. So they're doing a lot of this stuff in production. But basically, when it comes to resilience testing, it's very important to have this kind of like principles in the back of your head, which is fail fast and fail safe. So basically, you would like to fast as soon as possible with your issues, and then you'd like to fail in a way that you don't kind of like spill it on the whole system. And in this case, it's also really worth mentioning tracing. So for both performance and resilience/availability, that you need to know, because currently you're outside of of the same machine. So you can have hundreds or even thousands of processes, machines, containers, you name it. And you need to kind of like figure out what's going on. So it's very important to have logs and metrics in place, so that you can either like manually check the logs to see if there are any overflow of errors, or if there are any metrics that are indicating some issues, or maybe automatic alerts or something like that. So yeah. So now we can go to, now is the time to actually go into tools. So I'll briefly talk about actual things that we can use for implementing those techniques I was talking about earlier. So I split into 2 groups. The first part is developer tools. So as you can see, we have the first subgroup of this is in-process tools. So this means that well, if you're running your testing in Unity, you have access to the full API and everything is running more or less in the same process. You can have multiple threads in there, but they're still running in the same process. So you can debug it, you can see what's going on in there. So that's why I was saying that it also speeds up development, because if you tweak something in your test, and you can actually put a breakpoint there, and you can see what's the state of certain internal things that usually would be very hard to see. So yeah, first and foremost, stubs and mocks. So I think they're they're well-established patterns. So you either like implement the replacement, or you use some of the libraries that are available on the market, so that you replace something that you would usually inject into your service or class. Then there are coarse-grained unit tests. So this is something that I would say it's, so I was talking earlier about component tests or functional tests. So this is kind of like a technique that's how it's called. So you have coarse-grained unit tests, which means that instead of having just one class or one unit of code, you're kind of like making this unit way bigger. So it's, so for instance, you can have, you can use, say test server, NuGet package, and then you can spin up almost the whole thing in memory. Then there are well-defined contracts, so it's not necessarily a library, but again, I think this allows you to, first of all, you can plan with your contracts, and basically very often, if you have properly planned contract, it helps you to develop software in a better way, because you think about contracts and you think about tests, and then you think about a lot of things upfront before you even start the implementation. So you can catch any potential issues and flaws in the design much earlier. So which means that it's usually much cheaper and faster to fix. And also the side effect of this is that your well-defined contracts allow you to kind of like have more modularity, so you can test those things in isolation because you rely on contracts. And yeah, last but not least, I mentioned that about that earlier. So it's like in-memory testing framework, so you can have like in-memory database, test server. For instance, for Entity Framework has really good NuGet package that allows you to swap for in-memory implementation. If you're in the identity server, it can also run in memory mode. So this is probably a little bit more extensive than coarse-grained unit test, but again, it allows you to test a lot of things and basically everything within the same process, so you can always stop it, break it from, for instance, Visual Studio without any problem. Then there are machine level tools. So this is still happening on your machine, but it's slightly, you can still, most of the time you can debug stuff, but then it usually requires you to have something running in your background. Like for instance, you need to run, you need to run some sort of, I don't know, like mock server or something on your machine so that you can talk to that thing. So first and foremost, contract verification. So what you can do, what you could use there is you can use, for instance, Pact. It's really nice framework that allows you to basically verify if your contracts are okay. So basically, natural, the idea is that you're recording real. You have a kind of like man in the middle. You're running some sort of set of tests in there, and then basically it records it for you. And for instance, it supports many languages, but it supports .NET. And then basically, once you have this stuff recorded, you can build your test around that. You can use snapshot testing. So this is a technique well known to front-end developers, but you can use it in .NET as well. There's one of the packages that supports it is Snapper. So basically, you can verify if those contracts and make sure that they're processed properly and if they're presented properly. Then you can use WebDriver and headless browser. So if you're a front-end developer, what you could do is that you can spin up the whole server and you mock the APIs that you're usually talking to, and then basically you can write your test so it clicks on real elements and you see how it behaves. And to make it faster, you can run in headless mode, right? So you don't need to render and open the whole thing. It usually consumes much less resources and it's much faster. You can use local counterparts, I was mentioning earlier. So for instance, you can use local SQL database, you can use Cosmos DB emulator as an example, JSON server, mock server. There are plenty of things in the market. And it might be a little bit of cheating in here, but you can use like easily distributable counterparts. So for instance, you can use MySQL database in Docker, but I think it's very often, I think it's getting more and more popular that you can, if you're developing it on a cloud environment, you can use stuff like Amazon Fargate or Azure ACI, so that basically you're spinning up a Docker container in the cloud, but because of the fact you're paying for minutes, it's very cheap, right? And it doesn't kind of like slow down your local development machine. That, well, obviously the side effect is that you need to have internet access, but it has its pros and cons. Yeah.
Piotr, I will jump in with another question around here. You mentioned a lot of specific tools, which I think is very useful. Could you maybe expand on how would you make those work all together, specifically in a .NET environment?
Yep, sure. Yeah, you're right. That's very good question. Well, so I think I can give you quite a good example. So that's one of the things I was creating some time ago for one of the projects I was working on. So basically, I was creating like a test that was kind of like picking up all the endpoints on the API to make sure that they're properly secured. But without actually knowing how many endpoints are there and that kind of thing. So usually what you would do is that, okay, so you would go for Swagger on a real environment. You would just parse all this stuff, right? And basically you would go and hit all those endpoints on some sort of real environment, or spin up the server locally. And you would just go one by one and see how it goes, right? And see if it returns you for a 1 or for a 3, depending on the scenario. So in this case, what I did, I used in-memory stuff. So basically, I used a mixture of Swagger, but that was hosted on test server, so it was still running in memory. And then it was using identity server that was also hosted on test server that was using in-memory database. And I think there is some sort of other local counterpart of a database, so that you don't need to go outside of the system. So the bottom line here is that I think that speed up the whole process quite a lot. I think it was like 2 or 3 times faster than running in the classic way, and basically it was still using more or less the same techniques, right? It wasn't actually about changing the tests themselves. It was more about changing the setup, and basically the tests were reused. It cut down the time massively, especially the startup time, because keep in mind that in here, when you are using like in-memory counterparts, they're significantly faster because, well, they still need to load a lot of stuff in memory, but they don't usually have any other dependencies outside of .NET of .NET things. I mean, not always, but very often they're simplified. So because of that, they're usually faster by the order of magnitude.
Good, thank you.
Yep, sure. Very good question. Thanks. Yeah, so the other part is DevOps Tools. So this is the second group, and this is, I know it might sound weird a little bit, but on the other hand, DevOps are not testing it directly, but they have a lot of stuff that they can do to actually make sure that services are working as expected. So tools that are so those are groups of tools or techniques that are used once the service is deployed to a given environment to see if it's actually operating properly. I think the most obvious one and the most broadly used is running end-to-end multi-service integration tests on environment. So you deploy to dev and then you run some sort of set of automated tests like, I don't know, spec flow or something like that basically checks the very basic flows. But then you can also run the diagnostics at startup. So that kind of like goes back into what I was saying earlier. So just to reiterate that there is a piece of code that basically checks if, I don't know, like databases have correct schemas and correct versions, APIs are in the correct versions. Everything goes wrong, it fails down, and it stops working, so that you can see it instantly in the pipeline that on the deployment pipeline that oops, sorry, something went wrong, and your service is not working as expected, right? So you fail fast and fail safe before you even deploy thing, or just when you're deploying it. And then last but not least, metrics and dashboards. So whenever you're deploying, you look at logs, you look at some sort of certain dashboards. So for instance, if your throughput is still as high as it was, or is it going down a little bit? And I think the alerting techniques are extremely important here. So basically, so you don't need to look at like 20 dashboards, right? So you have like 1 or 2 maybe, or maybe not at all. But if anything goes wrong, if there are any anomalies, basically it just sends you notifications, emails, I know, Slack messages, or any chat messages saying, hey, something is wrong, take a look on that, right? And you see that, okay, the new service was deployed, some issues started to come up, so probably it's related to that deployment. And it's important that you don't have metrics and logs only on your production environment, but on all environments, so you can catch it as fast as possible and as early as possible. Yeah, so basically, I think we're going towards the end. So first and foremost, I think it's important to kind of like, plan before you code. So like I was saying, thinking about tests, thinking about contracts, because very often you can catch up things in the very early stages, and the earlier you catch it, the easier it is to fix. And usually, if you're planning within the team. So that means that, usually more people have more ideas, and it's easier to find a solution than just one person that ends up with a ticket and tries to solve it. The other thing that I would like you to keep in mind is to try to put as much of testing as possible into build time steps. So basically try to have this split into what's related to configuration and kind of like environment specific things, and what's pure logic of your application, and try to make this distinguishment, and then test as much of your logic as possible in isolation and detached from the configuration part, so that you can basically your tests are faster, right? Because usually build time tests are significantly faster than environmental tests. The next thing is try to reduce number of integration tests. So I've seen very often that there that people are saying, okay, we have like suite that consists of say like 500 integration tests, so they will pick it up. Yeah, you're probably right, but the problem is that they take like 2 hours to run, right? And you'd rather have as fast feedback as possible. So probably like 10 minutes, 5 minutes is okay, but 2 hours, well, you can do a lot of things within those 2 hours, right? So yeah, try to reduce. So think about how you can test other things with techniques I mentioned earlier, and maybe it's possible to avoid creating too many integration tests. And just don't get me wrong, I'm not talking about getting rid of all the integration tests. I'm just talking about being smart in here and just thinking about what can be tested on lower levels. And another thing, make sure your contracts are rock solid, because a lot of tests can be kind of like relying on those contracts, because if your contracts are rock solid, then a lot of things can be built upon that, and that's usually significantly faster. Then automate as much as you can, because as you've seen, a lot of dashboards, logs, and that kind of things, deployments. People usually make errors sooner or later, so if it's automated, it's usually very repeatable, so we don't have any typos or anything like that. And don't forget about logs and metrics. And now I just want to quickly summarize challenges that might happen, that might occur when you're trying to put into practice what I was saying. So I'll start with challenges. So challenges are usually related to standardization. Automation on the component level can be difficult, because you need to grab all the people and make everyone more or less agree on things. Again, and that kind of like implies the more complex changes can get more complex. So you start digging into it, and then you realize, okay, it's actually more complex than we thought initially. So it requires more time and more money. So that brings us to the third part, which is cost. So I mean, in this case, I'm only talking about short term, but still, it's time, tools. Sometimes you need to buy some tools if you don't want to invest in building them in-house, or you probably need some sort of extra trainings. There's learning curve, because people need to get used to those techniques and approaches. But there are some advantages of this. So it has huge savings on regression. So I can just give you from my own example, from my own experience, that we currently our regression in the project, on my current project, is cut down to, I think, like on each environment to maybe like 3-minute stops. So basically, the build time tests take about 4 minutes, and then we deploy to an environment, and then tests are running within 3 minutes. So altogether, the test time, say, takes no more than 10 minutes. So, and now think about how much time it takes in non-automated environment to test basically the whole subsystem. Also, advantages is catching up bugs earlier. So the earlier you catch it, the faster it is to fix, and the cheaper it is to fix. And also, I think it's very important from a kind of like human perspective, that confidence while refactoring or expanding a system. So you have the confidence that you have like a solid base that you're building on. So if anything goes wrong, you will be notified by it at some stage, right? So before it goes to the production, so you don't get a request from a customer saying, "Hey, something is broken," right? You know about it upfront before it even happens, and before it goes to the customer. And something that was actually put as a challenge on the previous slide now is put as advantage. And the reason I think standardization is actually a good thing here is that, well, once you have that in place, once you agreed on this, it's much easier from management perspective to kind of like shuffle teams, or even individual people to change teams if they want to, because I find different domains more interesting, because all the things look very similar, right? They test things in the same way. They have the same approach to contracts. They have the same, automated tools in place. So yeah, this is really a huge advantage for both people, but also from the company perspective. Okay, so I think that's more or less all I prepared for you. So if there are any questions, that would be a good time.
I'll just jump in. Thank you so much, Piotr. That was very, very interesting. Thank you for the presentation. Just a quick reminder on the ways to ask questions. So there are two main options. You can type in a question through the Q&A option at the bottom of your Zoom screen, or you can also raise your hand if you want to speak. So we already have some questions coming in. Piotr, the first one, we have Pablo Perez asking, how do you handle a system that has a lot of changes in parallel? Several developers adding changes at the same time. There may be a lot of problems on merging them all while testing.
Yep, that's a very good question, and that's usually not so easy. So basically, well, you have you're trying to what I would suggest there is to try to test those things as early as possible with build time tests techniques. So basically, you can run all the tests as much as possible to run on your local machine, so that even before you push to the repository when you're sharing the code with other developers, you can kind of like run those tests and see if everything is up and running as you would expect. Well, so that's one thing. Also, the other approach is that there are some techniques, like it really depends on your setup, but you can also think about having some sort of environments on demand, or it doesn't need to be full environment. It can be kind of like just partial environment. Especially, I don't know, if you're relying on Docker, you can kind of like spin up certain services there that they're good enough for you to test your thing. So for instance, imagine that whenever you're starting a PR, a pull request, it spins up certain services and it tests things. So even before people start reviewing your changes, the tests are already run, and you can see how it goes. So it's a difficult topic. It's not easy to answer in one word, but there are some techniques that you could do. So I think in one sentence, I would say try to put as much tests into build time as possible.
Very good. Another question coming in: what is your POV on test-driven development?
Yeah, so that's very, very good question. So I would say that I'm personally a fan. I don't think that it's like the only approach that's worth doing. However, I think it has certainly its own benefits. So it is a shift in the mindset in a sense, because you need to kind of like starting with tests. How does it even work, right? But after working with that kind of approach a little bit, I think, at least me personally, I can only speak from my own perspective. I noticed that it speeds up my development quite a lot. I know it feels a little bit weird because well, you're writing more code and you're trying to tell me that it's actually faster. Well, it is, because, well, I guess if you have a mobile app or something like that, it's probably you won't see that much of a difference. But if you have like a really complex system that consists of, say, like 10 services that you need to spin up just to test one of your things, right? And you need to deploy it to some sort of, I don't know, cluster or orchestrator or whatever, it takes time. So basically testing as much as you can with your tests upfront saves you a lot of time, because starting up a test suite is probably like seconds, whereas deploying stuff into your local things, even if you have like local environment in the cloud, clicking, starting, I know, from Postman or Insomnia or some kind of that tool, it just takes time. So it can be faster to actually do that, and then you're just doing one kind of like sanity check at the very end to make sure that everything is working. Or you can even skip that sometimes.
Very good. One question I see is, how do you agree on contracts?
Okay, so that's a good that's very good question. So yeah, how do you agree on contracts? Well, so so maybe let's try to put into perspective into a specific thing. So say you're designing an API. So I think that one of the approaches in there could be that you sit as a team. You gather requirements, and then you try to translate those requirements into your endpoints. So once you have endpoints, then you're thinking, okay, so what would I need there, right? So how would I design it? Maybe I would like to follow a little bit of REST, maybe not, but maybe those are just commands. So maybe we'll just pass only the stuff that we need. Well, do we want to tailor it for just one client because there won't be more clients, or are there there might be more clients in the future, so maybe it needs to be a bit more flexible. But what I'm trying to say is just by talking, there are like various techniques that allow you to kind of like discover what are the actual requirements. But once you have that, you can start thinking about how to design it, but just do it as a team, right? So you can combine and you can see how it works all together. And then once you have that in place, then it's easy to code.
Awesome. A few more questions coming in. Any specific recommendations for tools that orchestrate tasks against a collection of services that communicate asynchronously?
Well, so I'm not sure if there is anything out of the box. However, well, in the sense that like like test orchestrator or something. But for instance, one of the ways you could do it is that, given that you mentioned in the question is mentioned that it's asynchronous communication. So you're probably using a queue. So I guess from your test, you can subscribe to that queue as well. So you probably trigger your flow with some sort of either a message or an API call or whatever. And then you can subscribe to that queue and you can listen up for notifications to come from that queue, right? Or if you're using some sort of PubSub, well, basically, if you're using topics, you can subscribe to that topic as well, with your own queue dedicated just for tests, or something like that. Or just subscribe to whatever notification mechanism you're using, so that you can actually receive that. So if you're using webhooks, I think there are tools that can also help you with that. So for instance, one of the techniques you could use is ngrok. So basically, it kind of allows you to tunnel whatever comes to that generated URL so that it can channel back to your specific test run on an agent, right? That basically disappears after a couple of minutes once your tests are passed or not.
Very good. The next question is very specific. What is a good approach to testing stream processing, specifically audio stream processing?
Oh, wow. Okay. So I must say that I've never actually worked with audio stream processing, but I guess that in this case, I would try to. So I'm by no means expert in this, but I'll try to answer. So I guess that what you could do is that you could try, because I assume that the biggest issue there is probably related to the size of those streams, right? You don't know how big they are, and it can take quite a lot of time. So maybe you can try with small samples, basically run a lot of tests on those small samples, and then once all those kind of like basic checks are passed, then you can maybe go forward and basically again kind of like try with layers of automation, testing pyramid, and basically try to run cheap tests at the bottom and go up, right? So I suspect that in this case, cheap and fast might not be as fast as unit tests, but well, it's a very specific question, and it's really hard for me to answer without more context and not being an expert in the domain.
Fair enough. I think this is it for questions. Does anyone have anything else? I don't see more coming in for the moment, so I think we can probably wrap up. We're also kind of towards the end of the 1 hour we have allocated. So thank you very much, Piotr. It was really great. Thank you very much to everyone for joining us today. There were some very cool questions coming in. Just a reminder, this is the first day of a 3-day conference. We would have we do have more talks coming in, more speakers and more interesting topics. So we hope you join us tomorrow and on Thursday as well. We will follow up with, I see Piotr has some useful links kind of from on the topic. So we'll follow up with some useful information for you. And once again, thank you very much for joining us, and hope to see you in the next days. Thanks so much, Piotr, as well.
Yeah, thank you very much, guys, for attending. Thanks, Albana, for hosting and for arranging in such a good way. Thanks a lot, guys. Have a good one.
Have a great evening.
Thanks. Bye-bye.
Bye.